To verify the relationship between Verdet constant and wavelength. So we will try to establish the relationship between Verdet constant and wavelength, or how they are varying. So different wavelengths I will take by using the filters. This is the lamp which produces a white light, and this is basically the supply from where if you want to change the intensity of the lamp, you can change. No doubt, when the large intensity is there, naturally temperature will also increase. It will be heat production will be there from this lamp, and the water constant depends on temperature also. That I have seen. So try to have the intensity of lamp such a way so that water constant is not affected. This is a polarimeter from where the intensity of this light I will try to polarize, and this is other side of the polarimeter, other angles you can say, same polarimeter, so that I will try to rotate in such a way so that maximum light falls on the material through the electromagnet. This is the electromagnet which where this is here magnetic will be, this here the material will be there. This is basically probe to measure the magnetic field. So this is electromagnet to which current will be given, and current will produce the magnetic field, and this material will be there. Material will be there, and the current will be given from the power supply. This is a power supply from where the current is given to the electromagnet. So if with many time machines it shows overloading. Whenever the overloading is there, or this voltage and current knobs will be rated to 0, then reset it and then move slowly both the knobs together to have a maximum current. So both the knobs should be moved slowly together also, right, to have a maximum current to the electromagnet, because massive current will show the maximum rotation also. Now this is the basically polarity you can reverse by interchanging these black and red wires. Polarity you can change. This is a probe, because this current is given to electromagnet which will produce a magnetic field, and this probe will measure how much magnetic field produced. This is basically attached to Gauss meter from where reading we can take. This is the Gauss meter. So reading measured in his kilo Gauss first of all, and the scale I have taken 10. Mean whatever reading is we are getting, I am multiplying that with 10. And this is analyzer. Means whatever light is falling first from polarimeter, then we will set the maximum intensity, and from polarimeter it will fall upon the electromagnet. Then the material, because material is placed in between the two poles of the electromagnet, then it will fall on the analyzer, and analyzer will rotate in such a way so that maximum light falls on the detector. This is a photometer where we measure the intensity. Here the screen is there where it will show the reading. And this is the material. This is flint glass. It is square basically. So it is made. The glass is made of particular material. So whose Verdet constant we will try to measure. These are the filters we have been using. These filters are basically used to produce the different wavelengths. It is written also. This is wavelength 635 nanometer, 460 nanometer, 5540 nanometer, and 5 nanometer. So different wavelengths are there, and we will try to measure the Verdet constant at a different wavelengths and see if some relationship is there. Now this is the complete setup. This is the analyzer. This is a detector. This is the material, right? This is a probe. This is a photometer, and this is a polarimeter. And here is the filter. Some stand I have made on which filter is put, so that different wavelength, different light or different wavelengths can be produced, which will fall upon the polarimeter. And this is a lamp which produces a lamp, white light. It produces white light, and white light falls upon the filter, and then particular wavelength is falling on the polarimeter. And this is a power supply to the electromagnet, and this is a power supply to lamp. This is a Gauss meter, right? So if you want to reverse the polarity, you can reverse from here by interchanging the red and black wires. This is a flint glass, right? This is a probe I already discussed. Okay, so that is the first step. At no current, the electromagnetic reading on the Gauss meter should be 0. On set the Gauss meter to 0, because it understood that because no current is there to electromagnet, no magnetic field produced. Accordingly, it means reading on the Gauss meter should be 0. But sometimes it is not 0. Then try to adjust from the small knob is there. You can rotate that to adjust the magnetic field to 0. Now step 2, you can say whatever the name you can give, it is up to you. Step 2, no means no current. Set the polarimeter angle to the reading, and the photometer is maximum. So means we will rotate this polarizer in such a way so that reading on the photometer is maximum. So you take any filter at no current, this reading is maximum on the photometer at a particular angle. So that does not depend upon the filter. Now step 3. Now change the current to 6 ampere. It is up to you. You can fix 7 ampere also, whatever you want. 5 ampere also, because current I will not change. One it is fixed. So after all the filters, all the colors you can say, that reading will be fixed. Now when it is fixed, so maximum light through polarizer falls upon the electromagnet, and then on the material, then on the analyzer. And we will try to move the analyzer in such a way so that maximum light falls upon the detector, and accordingly this is passed on to photometer. From that reading we can check at what angle on the analyzer the maximum reading is there. Reading on the photometer is not used, but angle on the analyzer, right, that can be used to find the rotation. So you can do first for red filter, then you can change the filter, again since all the steps you have to repeat, then yellow, blue, green. I have taken the 4 filters. You can repeat. Current I will not change. So current will be not changed. Material is same. Only wavelength we are changing. So material is same. Current is same. Our whole setup is 0. Whole setup is same. Basically we are changing the filters only. Means for each filter, complete setup is complete reading is taken to find the Verdet constant. So this is the video basically at geocurrent. At geocurrent I will show. This is the geocurrent, right? So reading on the polarizer is rotated in such a way so the reading on the photometer is maximum. So when the polarimeter is set to maximum, so analyzer will be removed. Analyzer will not be the part of the this instrument, and we will remove that. Then when we fix the analyzer, right, then accordingly whatever light which is coming from the photometer, which is coming from the polarimeter, maximum light is coming. So again we will rotate the analyzer such a way so that reading on the photometer is again maximum. That is 6 ampere current I have fixed. You can see 6.02, 6.0 it is varying because of fluctuation of light. So this is basically lamp, this is filter, this is polarimeter. Red filter I have put. So this is falling upon this material. Then the analyzer, right? You can fix the angle
maximum light, maximum intensity will be, you will see from this photometer, right? Only the angle of the polarizer and angle of the analyzer and reading of the current, that is required for this practical. Now you can see here now. Current given was 0 first of all. Any current you take, same angle of analyzer will be there. So length of material is there. So basically angle of polarizer is only used so that maximum light falls from the analyzer. Otherwise we will not use for the calculation. Angle of analyzer also we will use only, right? And reading of the photometer also we will not use for the purpose of calculations. Okay, this is 0 ampere. Any color you take, angle analyzer and length of the material, and this Verdet constant will be accordingly. We can't calculate because angle of shift the shift can be calculated only. We take 0 ampere here, 6 ampere here. Accordingly, the magnetic field is this one. The red color is there, right? For the angle analyzer is 335, means 342 to 335. So shift you can see is 5 degree or 0.073 radian, and this is the length of the material. Whatever the fixed length is there, right? So accordingly I put the values. 5 means this value. 5 means shift, basically shift angle 0.073, and this is the length of the material, and this is the magnetic field, right? This way, this is the Verdet constant, right? So at different wavelength, right, different Verdet constant we are seeing. Then we will draw a graph between the wavelength and the Verdet constant, because practical is to establish the relationship between Verdet constant and the wavelength. So accordingly, graph is drawn, and this type of graph we are seeing. This black line is the graph, red line is shown automatically by the program. If you see, as the length is basically this wavelength is minimum, the Verdet constant is maximum. As the wavelength becomes maximum, Verdet constant becomes minimum. So this is inversely proportional basically, right? Same thing has been noticed in some of the such papers. So this was a such paper from 2018. So they have studied at different materials. These are different materials. Accordingly, you can see graph also at the minimum wavelength, right? The Verdet constant is maximum. This is maximum, and the maximum wavelength, this one, maximum wavelength, the Verdet constant is minimum. Immediately inversely proportional. Similarly, the another such paper of 2021, right, published in Optical Matters. This is an issue, right? So they have also checked the wavelength dependence, Verdet constant in this synthetic quartz glass. They have checked it. Here also we are seeing that Verdet constant is inversely proportional to wavelength. Thank you.